Hey guys, my name is Jolene and I'm currently a senior at Guam High School. This is my second year of calculus and I will be showing you in this video that calculus is so easy that you can do it anywhere and everywhere.
Today we will be looking at number 6 from the 2015 AP Calculus BC exam. This is non-calculator, so you will not be able to use your calculator. The question reads, the MacLaurin series for a function of f is given and converges to f of x for the absolute value of x less than r, where r is the radius of convergence of the MacLaurin series. Part A asks us to use the ratio test to find r. Ratio test is one of the various types of tests for convergence, and one of the most common. You just divide a sub n plus 1 by a sub n. It is recommended that you algebraically massage the whole equation in order to find like terms so that you are then able to simplify the entire equation. To solve for the radius of convergence, you first solve for the interval of convergence. You do this by taking the absolute value of the equation and find the limit as it approaches infinity. If you plug in infinity now, you are left with an indeterminate form, so before plugging it in, you can manipulate the function to end up with an easier form to solve for, and are able to apply your knowledge of end behavior and find the limit to be 1. Then you write the inequality as you normally would when dealing with absolute values and solve for x. What you end up with is the interval of convergence. In order to solve for the radius of convergence, you simply find the distance between the 2 points and divide by 2. And that's how you solve part A.
Okay, so I'll be honest with you, when I was trying to do this problem, I was stuck on trying to figure out how to find the radius of convergence, and I was kind of confused on the difference between the radius and the interval of convergence. So what I did is I reached out to different people, including Ms. Bamba and some other tutors like online for help. And so basically I want to tell you that when you're preparing for the AP exam or just for anything, don't be afraid to go out and ask people and try to use your resources that are available to you.
Now on to part B, and it asks us to find the first 4 non-zero terms of the MacLaurin series for f prime and to express f prime as a rational function. In order to take the derivative of f, we need the series. We are given the first 3 terms of the original series, and the problem asks for the first 4 terms of f prime. In order to take the derivative of f, we will need to know the 4th term of the series. We do this by simply plugging 4 into n and are given a value. Then you can easily take the derivative of those 4 terms. Next, you have to express f prime as a rational function. Looking at the derivative found, you should be able to recognize that it is a geometric series with a common ratio to be negative 3x. When dealing with geometric series, we know that the common equation for a sub n and are then able to plug in our known values, giving us our final answer.
So I also had difficulty with that last problem because I wasn't too sure what they meant by rational function. But after talking to some of the online tutors I mentioned earlier, they were just saying how it's one of the recognitions and understanding of when to apply what you know and how to do that. So basically you're being tested on what you know, so they're not going to throw out something that you're not able to do.
Finally, on to part C, which asks us to find the first 4 terms of the MacLaurin series for e to the x, and using that series to find the 3rd degree Taylor polynomial for g of x, which is a product of e to the x times f of x. E to the x is one of the most common MacLaurin series used, so you should be able to recall the first 4 non-zero terms easily. G of x is a product of the MacLaurin series of e to the x and f of x, so to define this function, you multiply the series and then just distribute. When you're distributing, be sure to take your time to avoid any error in calculations. remember that the question asks for the third degree Taylor polynomial, and because of this, you will not have to even look at any values found that have an exponent greater than 3. So looking at the products we found, we searched for like terms in order to simplify, and we are left with our answer. Excuse me. And that's the end of the problem. I hope this video helped you to easily understand MacLaurin series more, and I hope that 2 things that you can take away from this video is 1, to not be afraid to ask for help, and for 2, to take things slowly. So try not to rush things so that you don't make mistakes. Other than that, good luck with your future endeavors, and I'll see you maybe in the future.